Hi, my name is Annika Patka, and this is my Lab 4 report for Physics 1. The main objective of this lab was to observe a spring's motion from a video and use Tracker to extract data from it, to therefore create a GlowScript model. The diagram to the right shows how I extracted the data points from Tracker. To be able to do this, I used the data to derive a spring constant and relaxed length, as well as combine the forces and energy principles to have a greater understanding. As I previously mentioned, this lab focuses on the energy principle and the momentum principle. I use the energy principle in my calculations of kinetic energy, spring potential energy, and gravitational potential energy. I use the momentum principle to calculate gravitational force, spring force, and to update position and velocity. The force diagram to the left shows these two main forces, the gravitational and the spring force. There were two main calculations I did from the data I obtained from Tracker. After finding the average period based off of the data in Tracker, I was able to plug this period into the formula to get the spring constant. After finding the spring constant, I was able to use the force diagram and the momentum principle to then find the relaxed length of the spring. The force diagram is shown to the upper left, and the calculation is on the bottom right. Moving forward, I was able to apply these same principles into my GlowScript modeling. The first box shows the calculations of L hat, which is the direction vector for the spring force, and the stretch, which is simply the length of the spring minus the relaxed length. From here, the gravitational force and the spring force are calculated based off of their definitions. Gravitational force is mass times velocity in the negative y direction, and the spring force is negative ks times stretch times the direction vector. The last blue box shows the velocity and position update equations. I derived the position equations in the red boxes shown to the right, and the velocity equations in the orange boxes. At this point, I begin to use the energy principle in my code. I start with the various energy portions that contribute to the total energy: kinetic energy, gravitational potential, and spring potential. I derive each of these energies according to their standard derivative equations. From here, I set each of these equations equal to their initial values, as they'll be used within a while loop and will be calculating the change in these energies. As I mentioned, we would be calculating the change in each of these energies. This is because the changes in energy is equal to work. So to be able to do this, we need the change in kinetic energy, change in gravitational potential energy, and the change in spring potential energy. As you can see, I calculate each delta energy and then a delta total energy to match the equation below. It's these equations that'll be plotted to give us each of our energy graphs. After all of these code changes and my CSV file being uploaded, these are the graphs that are shown. The top graph shows the change in energy of the system versus time, and each of the different colored lines shows a different type of energy. The bottom graph, however, shows the position versus time, with the two curves being the Tracker data versus the model. The model in this case being the GlowScript code that I wrote previously. The discrepancy between the two models can be attributed to measurement errors in Tracker as well as rounding errors. So, putting it all together, what does this mean? We use the energy principle and the momentum principle, but was the energy principle satisfied? Looking at the graph and looking at the equation, one can see that the energy principle is in fact satisfied, as the orange line that represents total energy remains at 0. This is fascinating to see that based off of a simple video, we were able to extract data and apply physics principles to get an accurate model. So what if we use the y position instead of the x position data to calculate period? When I completed the calculation to tell the difference between the two periods, I got a difference of about 0.11 seconds. The two main factors that could cause this are the elliptical movement of the spring and measurement errors in Tracker, such as not using the center of the mass the whole time. Essentially, this 0.11 second difference would lead to a different spring constant and spring force, which would then alter the experiment.